So let's try first by peeling off a secant squared, because I do see there's a secant to the fourth power. So carry along this tangent to the fifth and break this secant to the fourth up into secant squared, secant squared. So it's really important to keep this secant squared dx like all separate to the side so that you identify for yourself and for me that that's what you're making the du. And so then what's the u? The u would be tangent, because you know the derivative of tangent is secant squared. Okay, so then let's make sure that I've got this u substitution that will work. So if I want to make u equal tangent, oh, look at that. That will be taken care of. This is going to be the du, so I just need to change this into tangents. So that's where you just have to know these identities. So, let me look at my eraser here. So you need to know the identity that secant squared of x is equal to 1 plus tangent squared of x. Oh, will you look at that? I can take out secant squared and substitute in 1 plus tangent. So go slow so that you carry everything along. Tangent to the fifth. So secant squared gets rewritten as 1 plus tangent squared. And then the secant squared, it just carries along. Okay, so now does my u substitution work? If I let u equal tangent, yes, I get u to the fifth. If I let u equal tangent, yes, I get 1 plus u squared. And then du is this, right? So that's du. So I just have to multiply this out. So u to the fifth plus u to the seventh du. So 1/6 u to the 6th plus 1/8 u to the 8th plus a c. And then replace the u with the tangent. So I get 1/6 tangent to the 6th plus 1/8 tangent to the 8th plus a c. And if you don't put the plus c in, I am not going to be that concerned, because these problems are long and hard. All right, so now let me get my eraser going. So now let's do it the other way, because it can be done both ways. Not many problems can be done both ways, but this one can. So last time we pulled off a secant squared for the du. Okay, so what happens if we pull off a secant and a tangent? Let's check it out. Okay, here we go. So if I take this and I say, okay, I'm going to be left with a tangent to the fourth and a secant cubed if I take off a tangent x secant x, secant x dx, right? Because I'm peeling off the powers. So I'm looking at what I've got left over. So this tangent to the fourth times this tangent, that gives me tangent to the fifth. And then this secant cubed and this secant, that gives me secant to the fourth. Okay, so then this is my du. Secant x, tangent x. So that means my u is secant. Okay, so I need to make u equal secant work. That will be taken care of. This will be taken care of with the du. So then it's my job to replace tangent to the fourth in terms of secants. Let's think about this. Tangent to the fourth, I would need to write that as tangent squared squared. And then I'll just carry this secant cubed x and this tangent x, secant x along. So remember, I'm trying to make this u substitution work. So I need to rewrite this. So you have to have memorized the fact that tangent squared x plus 1 is secant squared of x. So I can replace this with, and go slow, this would be secant squared of x minus 1. And then carry along the secant cubed, tangent x, secant x dx. Okay, so now let's go do the u substitution. So let u equal secant. So that's u squared minus 1 squared. U is secant, that's u cubed. And then this gives me a du. So now I get to go and multiply it out. So I have to multiply this thing out, right? And you know how to do that. So that would be u to the 4th minus 2u squared plus a 1 all times this u cubed, right? This u cubed du. So let's do one more step here. So I'd have u to the 7th minus 2u to the 5th plus u cubed, whoops, du. Now take the antiderivative. So it gives me 1/8 u to the 8th minus 2/6 u to the 6th plus u to the 4th over 4 plus c, and then put the u back in, which is the secant. So 1/8 secant to the 8th minus 1/3 secant to the 6th plus 1/4 secant to the 4th plus a c. Wow, long problems.